Welcome to our presentation from the House of Samson. Today we're excited to delve into some fundamental concepts in statistics: mean, variance, and standard deviation. These measures are essential for understanding data sets and drawing meaningful conclusions from them. We'll start by discussing the mean. Mean, it is also known as the average, is a measure of central tendency of a data set. This represents the expected outcome of a distribution. This is denoted as mean, and it is calculated by summing up all the values in the data set and dividing them by the number of values. For random variable, the mean or expected value is calculated by multiplying each possible value of the variable by its probability, then summing the results. Next, we will explore the variance.
Variance measures the dispersion of the dataset, indicating how much the values differ from the mean. This is denoted as sigma squared. It is the average of the squared differences from the mean. For a random variable, variance is calculated by taking the expected value of the squared differences between the variable and its mean. Finally, we cover the standard deviation.
The standard deviation is denoted as S squared, which is the square root of the variance, providing a measure of the spread of the dataset in the same data units as the data. A lower standard deviation indicates that the data points are closer to the mean, while a higher value suggested greater variability. For a random variable, it quantifies the typical distance from the mean. Mr. Arkel wants to add more information.
In addition to all of that information, the mean, also called as the average, is a way to find the middle value of a set of numbers. For example, if you have 5 numbers, 1, 2, 3, 4, and 5, the mean is 3. This is because the sum of number is 15, and when you divide it by 5, the number of numbers, the result is 3. And now, for a random variable, Ms. Ariel, can you please share it with them too?
Okay, sure. For a random variable, the mean represents the expected value you would get if you did the same experiment over and over again. For example, if you toss a coin 100 times, the expected number of getting ahead is 50. This is because the probability of getting ahead is 1/2, and the mean is 100 times 1/2 is equals to 50.
We create a scenario and a table wherein it would apply our understanding in mean, variance, and standard deviation. Later on, we will show you on how to solve it. Ms. Silva will discuss the given scenario.
Here's our given scenario. In a small city, a man named John went to a casino to play a color game that doubles your money if you win. John bought a ticket for the entrance fee that worth 500 pesos. He bet 20,000 pesos, 10,000 pesos, and 5,000 pesos for red that has a 50% probability to come out. Construct a table and solve for the mean, variance, and standard deviation. To solve for the given table, Miss Erma will explain it to you.
To get the gain, we need to minus the 20,000, 10,000, 5,000, 0 for no win, to 500 pesos. The result would be 19,500, 9,500, 4,500, and negative 500. For probability, it is 0.50 or 50%. Why is that? When he places bets on red, the probability of winning for each individual remains the same, 50%. This means for each of his bets, 20,000, 10,000, and 5,000, he has the same probability of winning. For negative 500 would be 0.998. Before we get the mean, it is needed to square the value from the gain, which is the x. Now, let's move to the mean. We need to multiply the gain in probability.
The first thing we need to do to get the variance is calculate our previous answer, square the value from the gain, which is the x, then we will multiply it to the probability. We will minus it to 16,500 squared, and our variance is 26,750,000. Finally, to determine the standard deviation, simply square the total from the variance.